Hey everyone, Gene here. Welcome back to another episode of our Java Deep Dive. Today we'll be diving into the fascinating world of multithreading, specifically focusing on synchronization. This is the third video of my Java multithreading series. If you missed the last one, be sure to check it out. Just head over to the playlist Java Advanced. Now, you might be wondering, why do I need to know about synchronization? Well, let's say you're building a high-performance application. Without proper synchronization, your threads could clash, leading to unexpected and sometimes disastrous results. So buckle up, because we are about to unravel the mysteries of race conditions, data races, and deadlocks. And yes, we'll be coding along the way to make it all crystal clear. Imagine a busy intersection without a traffic light. Chaos, right? That's essentially what happens in a race condition. Multiple threads access shared data, and the outcome depends on the unpredictable order of execution. A more specific scenario is a data race. This occurs when two or more threads access the same memory location, at least one of which is a write operation. It's like two people trying to write on the same piece of paper at the same time. But fear not, we have a solution: synchronization. Synchronization is like a traffic cop, ensuring that only one thread can access a critical section of code at a time. This prevents race conditions and data races. We'll be using Java built-in synchronization mechanisms such as synchronized blocks and methods. These constructs guarantee mutual exclusion, visibility, and atomicity. But be warned, misuse of synchronization can lead to deadlocks. It's like two trains stuck on the same track, unable to move. We'll explore this in more detail and learn how to avoid it. Now let's put theory into practice. We'll start with a simple synchronized counterexample to illustrate how synchronization works. Alright, so let's take a look at how to build this in Java. So the first thing we want to do is create ourselves a new method called synchronized counterexample, which we define as private static void. And inside this method we want to define the comments first. So define system load, define what to do, start all threads, wait for all threads to terminate, and print the results. Alright, so let's start with the first point, define the system load. Here we define ourselves two variables, increment number and thread number. Increment number we set that to 1,000,000, and thread number we set that to 100. Those are values that we will use later in the code. Increment number is the number of, increments in a for loop that we use to add one to a counter that we will define. And thread number is the number of parallel threads that we will define ourselves. Alright, so now we need a counter variable. And for that we create ourselves a new counter class, public class counter. And within this counter, we define ourselves a new variable, number. So it's a private long number, and a getter for that. So a getNumber method, which returns this number. We will also define ourselves a second method, increment number, to add 1 to the number that we have. That's all we currently need for the counter class. So let's go back to the synchronized counter example method and define ourselves a new variable, final counter, counter, and a new counter. Alright, next we can define ourselves what to do. So for this we define ourselves a new runnable, in which we override the run method, and in here we define a new for loop, running from 1 to increment number, which was 1,000,000, and in every iteration we increment the counter by 1. Alright, let's go to the next comment, which was start all threads. Let's start by defining ourselves a new list of threads, which we call threads. It's an array list that we define, and right after that we define ourselves a for loop again, which starts at 1 and runs until to the number of threads that we define, which was 100. And in every iteration we create ourselves a new thread and pass the runnable variable r for it, and after that we start the thread. Alright, let's go to the next comment, which was wait for all threads to terminate. Here again we make use of another for loop, running through all the threads. And in every iteration, we make use of the join method to wait for the thread to terminate. Alright, let's go to the next comment, which is print results. And here we want to start by making use of printf to print counter should be, which is the increment number times the thread number. That's the total number of increments that we expect from all threads. And then we make use of printf again to print out the number that the counter actually has, which we do by printing counter.getNumber. Alright, let's go up to the main method and run the synchronized counter example method, and then run the application. And here you can see the result. What the counter number should be is 100 million, but what the counter actually is about 72 million. So there's a little difference between what we expected and what we get. So let's take a look at the counter class again. Here we can see that we increment the number in the public void increment number method, and in here with this.number++, which essentially comes down to a set of 3 commands: getting the number value, adding 1 to it, and writing it back to this number. Now imagine all the threads doing this at the same time. At one point or another, they will end up overriding each other's values. So this is why we don't get the value that we expected. Now, how could we repair this? And this is actually very easy. We just add synchronized, which means that within the increment number method, only one thread at a time can enter. And all the other threads will have to wait outside and wait for their turn. This way we guarantee that no thread will override the values of another one. Alright, let's try it out. Let's run the application again. And here we can see the counter should be 100 million and the counter is also 100 million. And that's exactly what we wanted to have. Next, we'll dive into a deadlock scenario. We'll create a situation where 2 threads are waiting for each other, leading to a standstill. Alright, let's go back to the code segment and create ourselves a new method, deadlock example. And before we begin, we create ourselves another class, deadlock counter, in which we define ourselves 2 long variables, one for counter A and one for counter B, which we both set at 0. And we also define ourselves 2 more variables, log A and log B, both being instances of objects. Then we define ourselves 2 methods, increment A and increment B. In the increment A method, we increment counter A by 1 and output its value. In the increment B method, we increment counter B by 1 and then output its value. Now we go to the increment A method and add a synchronized block around its functionality, which we point to log A. Then we add another synchronized block, which we point to log B. Then we go to the increment B method and do essentially the same thing, but the other way around. One synchronized block for log B and another synchronized block for log A. We can also create an output for this. So let's go to the increment A method and use println, first log A, second log B, and the value for counter A. And then we go to the increment B method and also add a println, first log B, second log A, and the value of counter B. Now let's go back to the deadlock example method and add a new variable counter of type deadlock counter. And right after that we add a runnable, R1, which overrides the run method. And in here we create ourselves a new while loop, which is always true. And in every iteration we increment counter A by 1. After having done so, we send this thread to sleep for 500 milliseconds. Then we create ourselves another runnable, R2, which essentially does the same thing, but within every iteration of the while loop, we increment counter B. Alright, let's create 2 new threads. One thread T1, which runs the runnable R1, and one thread T2, which runs the runnable R2. Now let's start both threads. Next, let's quickly go to the main method to disable the synchronized counter example method and add the deadlock example method. Now let's run the application. Now here we can see that the counters both count up. And it might take a little while until one gets stuck, but if you wait long enough, you're going to end up in a deadlock scenario, which in this example is when the counters both have 86. Now we have the situation that one thread has entered the synchronized block of log A, but is waiting for log B to be lifted. And at the same time, we have the second thread which has entered log B and is waiting for log A to be lifted. And this is a deadlock scenario. The threads will not be able to leave this section. And the only way to get out of this is kill the entire application. By understanding these concepts and practicing with code examples, you'll be well equipped to build efficient and reliable multi-threaded applications. So there you have it. We've covered the basics of Java multi-threading synchronization. Remember, it's a powerful tool, but it requires careful handling. If you found this video helpful, please give it a thumbs up and subscribe to stay tuned for the next episode. We'll explore advanced synchronization techniques, including the wait and notify methods. Thanks for watching and happy coding.